Hi everyone, Professor Mankowski here. In this video, we're going to talk about Chapter 3, Section 3-1, Measures of Central Tendency. And measures of central tendency refers to what value or what values in the data set do the observations tend to converge towards. And we have three different ways of measuring that, with the mean, the median, and the mode. The mean is the mathematical average. Most of you have probably all calculated the mean. And the mode and the median are not necessarily as powerful as the mean mathematically, although they work in situations when the mean would be completely useless. So we're going to learn what all three are and how to go ahead and not only calculate them, but find out what are the advantages and disadvantages of using each one. So we'll know under what circumstances which one should be used at what time. Now, in Chapter 3, we're also going to find out that there's a lot of shorthand abbreviation symbols that we use when we're setting up our formulas. So we're going to start with the mean. At the same time, we're going to start to learn a lot of those symbols rather immediately, right away. So when we calculate out the mean, the mathematical average, we're going to consider we have 5 students that have just graduated from Bergen Community College. They received offers. And we want to know how much money they're making, because if it's a small offer, if it's an offer that we don't like very much, maybe it makes us think twice about graduating from school. Or if it's a really good offer or really encouraged to graduate. So we've got 5 different observations that we're going to look at, and our job is to average them. So the first student, or the first graduate, we're going to call X1. So X1 is going to denote the first observation we have. We're going to set that at $25,000. The second graduate, we're going to call X2, $35,000. And we're going to put in the rest of the 5. Now, if we were going to calculate the average of all these numbers, the mathematical mean, we would start by adding all the numbers together. So I'm going to begin by generating the pattern. I'm going to take the 25,000, X1, add to that 35,000. But being humans naturally lazy, we don't want to write out all 5 numbers, and we think, how do we do this more quickly? We're going to use a symbol called an ellipsis. And the ellipsis means that we have this ongoing pattern. It keeps going until we stop it. And we stop it by putting the last number in position with 30,000. Okay. So we're going to take all those, we're going to divide it by 5, our total number of observations. If we had a whole lot of graduates we were working with, maybe 5,000 or 10,000, even using the ellipsis, it's still a lot of work to show we're adding together everything, even with the 3 dots. So easier way of doing this. What else can we call the 25,000 that would be shorter than writing out 25,000? The answer is we can call 25,000 the X1 observation. And we can add to that X2 and so on until we get X5. And we're going to divide all those by 5. Now, writing X1 plus X2 plus X3 all the way out to X5, it saved us some space. And there's even a more succinct way that we can do this. If we look in the numerator, the mathematical operation that we used was addition. And in statistics, we have a symbol that looks just like this. It's like a funny looking E, and this means to add. Now, we don't know what we're supposed to add until we see something written next to it. So we're going to write in X because we want to add up all the X's. And then what we're going to divide by is lowercase n. Right? Lowercase n stands for the total number of observations. So this whole entire fraction is going to collapse down to what we call X bar. And X bar is going to be our symbol for average. And that you need to memorize because we're going to see that everywhere, X bar average for almost the rest of the course. Now, in the textbook, we're also going to see another symbol that looks like a U with a hook hanging off the left of it. Now, this U with the hook is pronounced mu. Now, why are there 2 different symbols? Well, are statisticians just trying to make our lives confusing? And the reason is mu is going to be the average of the population. X bar is the average of a sample. And back in Chapter 1, when we talked about populations and samples, we mentioned that we have to be really careful to be able to have some way of showing somebody where the source of our data was from. So we would have to have a way of showing if our average came from a sample or from a population. Okay, so if we know that mu is a population average, arithmetically, is it calculated the same way as x bar? Yes, it is, but we have a slight difference in formulas. Our mu is going to be, in our numerator here, the sum of x's, but in the denominator, we're going to use a capital N. And the capital N is just there to stand for the total number of observations, but in a population instead of in a sample. Okay, so with symbols, what we have to remember is x bar, sample average, mu, population average, n is going to be the total number of samples, lowercase n, total number of observations in a sample, and capital N, total number of observations in a population. The large N, the capital N, we're not really going to use very many places more in the course. There's actually just one more spot where we're going to see it. And then for the rest of the semester, we're just going to be working with little n, lowercase n the whole time. Okay, so median is going to be next. Now, when you think of median, like the median in the road, what do you think of? And we would say, well, gosh, median runs right down the center, so we think of right down the center. In mathematics, it means the same thing. It means the halfway point to our data set. So let's get into a nice example. We graduated from Bergen Community College, and we have an offer. We want a nice car, a used car to drive. So we're going to go down to a used car dealership, and we need to get some prices. We need to know how much prices of those cars are so we can set up a budget. And we go ahead and we get these prices on the used car dealership, and we want to know what's the median price. So the first thing that we need to do is we have to take all these numbers and we have to arrange them in order. So we're going to do that by building what we call an array. An array just means get the numbers in order from least to greatest. And when we do that, our median is going to be the number straight in the center, which is going to be 7,000. So that means we want to buy a car from this used car lot. We want to budget probably $7,000. Now, this was a relatively simple data set because there's an odd number of observations. If it's an even number, things would change just a little bit. If we want the median now, we can't exactly go straight into the data set and find the middle number because we really don't have one. So what we do is we have to go and we have to identify the two innermost numbers, and we're going to take the average of those, and that's going to end up being our median. Now, there's one really neat thing that you can do with the median. One really helpful situation where the median gives us a big advantage. Imagine that that last vehicle was not priced at $27,000. Somebody that's a very wealthy person, they owned a Bugatti, wants to trade in their car. So now we have a Bugatti, and Bugattis, if you don't know, they're very fast cars. They go from 0 to 300 miles an hour in maybe like 6 seconds. So the price of this Bugatti is at $12 million sitting on the used car lot. And if we were to try to get the mean of the data set, the mean would just be nonsense now. It would be something like, $2 million. It's totally useless. But if we look at the median, notice how the median didn't change a fraction of an inch. And that's because when we calculate the median, all it can see is the total number of observations in the data set. It is blind to what's the highest and what's the lowest number. So that means when we calculate out the median, it's going to be really helpful to use in a situation where we have very high numbers or very low numbers, which might even be potential outliers in the data set. So that's going to be our big takeaway that we want to use. Okay, so our last number is going to be the mode. And the mode is going to be the most common number in the data set. So if we are maybe graduating, we're an accounting major, and we're interested in knowing a little bit about what people are making that graduate with accounting degrees. That can help us a lot at the negotiating table if we get an offer, right? So we have some salaries of different people who have graduated. We want to know what's the modal offer, like what's the most common offer you get. If we go ahead and we take a look at our data set, it's going to look like we have 33,000 as our modal offer. How many occurrences do we have? 4 occurrences. So important things to know about the mode. Our data set can have 2 modes. It can also have 3 modes. So it can be bimodal or it can be trimodal. And if that happens, we would refer to our data set as multimodal. Now, the data set might also have no mode. If you don't find one, don't worry. It doesn't mean you did something wrong. It just would simply mean that you don't have any number that's more common than any others in the data set. Okay, so what is the most significant benefit of the mode? It's that you can use the mode when you have qualitative data. So if you don't have numerical information, you're maybe just listing people's hair color, red hair, blue hair, blonde hair, going around a classroom or an office, or even just walking around on the street. You can't really calculate a mathematical average of hair color, can you? But you could find out what's the mode, and then from a statistical analysis point, especially in marketing, really valuable information to have. Okay, so what would happen when we put the mode, the mean, and median all together at the same time and use them? Let's think of a histogram for just a moment. We looked at a lot of histograms in chapter 2, so let's look at one more histogram. This histogram appears to have a symmetrical bell shape to it, and when that happens, if we think of where our 3 measures of central tendencies would fall, our median would be right in the center, and I have to reposition my screen because I have something blocking my view here. Okay, well, we'll start with the mode, and the mode is going to correspond to the frequency class that has the highest number of observations. And we could identify by looking for the block that's the tallest, that's going to be right in the center. Now, where do you think the median would be? Now, the median, remember, it's the halfway point straight through the data set. So if we have a symmetrical data set, the median should also be right smack in the center. And the mean, well, if our data set is symmetrical, the mathematical average would be the number also about right in the middle of the data set. So what this tells us is if we didn't have a histogram, we just had a data set, but we were able to calculate the mean, the median, and the mode, and all those numbers were very close together, it's telling us that our data set is potentially bell-shaped, isn't it? So let's look at one other scenario. If we have a data set that looks similar to what we looked at before, but this time it's got some extra blocks on the right side, meaning it looks like it has skew. If we consider the different shapes histograms that we learned about in chapter 2, this histogram would be right skewed. Now, what would be different about the mean, median, and the mode here? Well, if we think about what would happen to the mean, now the mean is going to become a lot higher because it has to respond to all these observations in green that are now much higher that weren't there before in the last slide. So that means the mean is going to slide out to the right. The mode, well, the highest data block is still structured right there, a little bit to the left of the mean. So the mode will be less than the mean. Now the median is going to be in between the two. It'll be raised a little bit higher, but because the median marks where the halfway point through the data set is, we still have the lion's share of the data set on the left side of the histogram. So it's going to stay close to the mode, although it will move a little bit higher because we have the extra numbers coming in on the high side where the green blocks are. So here's your big takeaway. If you find out that the mean is greater than the median and the median is greater than the mode, that's letting you know that you have right skew in your data set. If you had left skew in your data set, it would be in the opposite order.